Hello, everybody. I hope you're having an excellent NSO Developer Days. We are very happy to have you here in one of these parallel tracks that are going on. And thank you for choosing us. And I'm not surprised you did, because we have today a very interesting and very important topic, a topic that is recurrent in Developers Day since the first time. So every year, we do have a service reconciliation or service discovery session just to highlight the importance of this topic, correct? How important imperfectness is for all of you. I'm particularly happy because for the first time since we started, we're going to have non-Cisco people talking about service reconciliation. So that is extremely important for me and for everybody that customers and partners start talking on our behalf. So we have two distinguished speakers joining us today. We got Rob Hinst, who is a principal engineer on Crown Castle, and he's been working with NSO since 2014 and as an NSO customer. And secondly, we're going to have Scott Barvick, who is the CTO of North America from Ductus, and really much an NSO guru that has been working with NSO and previously NCS since around 2012. So without further introduction, let me pass the ball to our speakers, and please enjoy the meeting. We're going to have some polls using the mobile app. Then you're going to know about it. You can ask your questions on the Q&A panel in the WebEx application. Okay, the floor is yours.
All right, thanks, Roque. So this is just going to be a quick presentation about how at Crown Castle we've sort of developed a methodology for learning to live with the fact that we don't have a fully automated network and that things go out of sync and how we deal with that. First, I want to talk a little bit about Crown Castle. So for anyone who's not familiar with the company, we are an S&P 500 company, and we just recently actually made the Fortune 500, so quick plug for us there. So Crown Castle as a corporation owns and leases out mostly cell towers and small cell technology to large mobile providers nationwide in the United States. But within Crown Castle, there's Crown Castle Fiber where I work, and so we've got a nationwide fiber network that sort of supplies those devices in other enterprise companies. So we've got about 80,000 route miles of fiber spread out over a dozen legacy networks. So I'm sure many of you have a similar story, many mergers and acquisitions combined to give you a nice, neat little network where there's only one platform, right? We sell dark fiber, IP services, Ethernet services, and wavelength services. And like I said before, lots of different vendors on board. Anyone you can name, we've probably got. And as a result, there's lots of change. It's constant, fast-paced. It's hard to keep up with from an automation standpoint. And thankfully, and as of necessity, we've got top-notch engineers at Crown Castle. The operation teams, keep everything running smoothly. But between you and me, there is one dirty little secret they like to keep, and that is some of them are actually human. And humans do make mistakes, as we all know. So, and a lot of times, it's not even mistakes or doing things wrong, but people have their own stylistic preferences, whether it's, painting a picture or crafting a network configuration. And that's a problem because NSO wants everything sort of uniform, and it's not just NSO, it's just, it's important to have everything uniform, especially going into an age of increased programmability, not just for the network, but for everything we do. So in order to progress towards pervasive automation, we need to find a way for uniformity. We need to find a way to play nice with humans who are not always as uniform, and that's what we're here to talk about today. So the first thing I want to do is take a step back and go all the way back to the honeymoon, when you all first got NSO. Actually, Scott, if you want to go back to that slide. So when you first got NSO, you got home, you tore it out of the box, right? Because that's how it works. And you developed a bunch of great automation models, and everyone loved them. Everything went faster, less errors. You're a hero. But then they go back to you and tell you, hey, we have all these services that were deployed before we had NSO, and they're not eligible for automation. They're not in CDB. How do we apply your automation routines to these pre-NSO services? And thankfully, there's a pretty, at this point, well-established pattern for doing that. You can import your services into NSO. You just break them down into service parameters as if they were brand new services you were creating. You set those parameters in NSO, and you commit it, no networking, or you can just commit it if you're like to live dangerously, and away you go. And everything's great, and then you can do automation, right? All right, well, not so fast. So at least in our experience, and I think this is common, and this is why we're giving this presentation, is, you do that and a lot of those services are out of sync. And it doesn't mean that they're not working. It doesn't mean that they're necessarily misconfigured. It's just that they don't exactly to a T match your service template in NSO. Maybe it's even a case sensitivity thing, right? Which most people wouldn't consider wrong. But so we can't just fix that by redeploying to the network, because these services were imported using data and values, at least in our case, from our OSS and BSS databases. We drive all of our automation through the OSS database so that people don't have to do, for example, redundant data entry to enter parameters that have already been documented for a service, and it cuts down on the time to deploy as well as errors. But the BSS OSS database, what have you, might be wrong. People aren't perfect, like I mentioned. It could be out of date. Maybe somebody forgot to update something or is in the process of doing so. Or, a thing we found a lot is in older records for older services, before we really stressed data integrity and making sure things were machine readable and things like that, important service parameters were sometimes just documented in free-form notes fields. People either didn't have a field to explicitly document something, or they weren't aware of it. There's a couple of approaches you can take if you need to get things back in sync. And one of them, and the original approach that I thought was sort of the only way, is doing the research to figure out which of these data sources is right. Is the OSS right? Is the network right? Is NSO right? Are two of them right and one's wrong? And there's a lot of research that goes into that. It's time consuming, it's complicated. And sometimes you really don't know. There's not a good way to tell. You can see what's sold, but that doesn't tell you which VLAN it should be using. So, we decided to take a step back and kind of reevaluate what our goals were. So, like I said, making everything quote unquote right would be lovely. And it's an important thing, don't get me wrong, but we'll probably do that tomorrow. In the meantime, me, not as a network engineer, but rather as a software developer, my task and my goal and my mission is to automate more things on the network, to provide ways to do more automation on the network. And in order to do that, we need to synchronize our data sources. And by data sources, I'm talking about our OSS database. I'm talking about NSO as a data source. And actually, I kind of consider NSO two different data sources. When you look at the services branch, where your service instance and service parameter data is stored, and then the devices branch of NSO. And then thirdly, the actual network itself, which may or may not match your devices branch within CDB. So how do we go about doing that? So this graphic shows the methodology that we've developed in partnership with Ductus for the lifecycle of a service on the Crown Castle network. So if you just kind of take a second to concentrate just on the three green arrows I'll go through. So starting off with service parameters coming out of the OSS. So this is the standard create workflow for a service in NSO. You first input some service parameters, usually stored in the services branch of NSO. You can do this a number of ways. You can enter it on the command line through NCS CLI. You can enter it through the NSO web GUI, or you can pick a northbound API and get them in that way. So like I said, we drive everything through our OSS database at Crown Castle. So we have applications that extract values from the OSS database, transform those to look like our NSO service parameters, and commit them into NSO through a northbound API. So once they're there, like I said, I consider services a separate data source than devices in a lot of ways. The way it gets over from services to the devices branch is through the FastMap algorithm and the templates and service packages that we've developed that map our service parameters to device parameters. And then finally, once data is written to the devices branch, as you all know, that triggers a write out to the network via netconf preferably, if not CLI. And then that's kind of where the create stops. And then life happens. People edit things on the network. People troubleshoot things. Things get changed for whatever reasons. Sometimes upgrades are performed out of band for whatever reasons, good reasons and bad reasons. And things go out of sync. So we run a nightly compliance audit using the inbuilt NSO compliance reports feature, which is great. It tells you what services are out of sync. It gives you a machine readable XML output for that we ingest into a database that we can parse out and figure out how many services do we have out of sync. Are our services becoming more or less out of sync? And then from there, we can actually see the dry runs and sort of start to address, okay, well, we see lots of XYZ problem cropping up. So then on an automatic basis, then what we're in the process of building, what we're close to having complete is a level of automatic service reconciliation. So this is the part that I said is time consuming and hard to get right and complex. And obviously the service reconciler that you see pictured here, it's not going out to all these systems. It's not talking to people to figure out why they made changes, right? So it's doing what it can do. And in this context, what it's doing is it's invoking an action in our service packages called reconcile. It's not anything revolutionary, but when it came out, it blew my mind. So I read about an article on NSO Developer Hub that Dan Sullivan wrote a few years ago now, and essentially he talks about getting your service parameters correct in CDB by reverse mapping the data in a devices branch. So much the same way when you create a service, you fast map from services to devices, you can use the same sort of logic to reverse map devices back to services, right? And quote unquote correct things there, or at least get them in sync. So we do that. We write the data back to services. Now it's not completely deterministic. It's hard when there's not a one-to-one correspondence between a single parameter in your services branch and a single parameter in the devices branch, right? If you've got a combination of service parameters being combined to configure certain settings in your devices branch, you got to know how to split them. There's some logic that needs to be applied. In some cases, it's just impossible. But we do what we can, and we reconcile a high degree of services that way into the services branch. At least that's the idea. And then, so when Dan does this presentation, that's sort of where it stops. And I just kind of wanted to point out there's an extra step, at least from our point of view, that's important because, like I said, and I'm going to say it again, we drive all of our automation through our OSS database. Not a lot is hand entered through the NSO GUI or anything like that. So if somebody came back, let's say we reconcile this all the way up to the services branch and we stop there. Next time somebody comes in to do an upgrade or a change on that circuit, it's going to be driven through the OSS database, just like all our automations, which means it's probably going to pull a value that was originally used to create the service that made it go out of sync in the first place. It could be wrong, it could be right, but it's certainly not going to match the perspective of that service that our other data sources have. So it's important to write the data from the services branch back into the OSS database. And the way that we've come up with to address that is we diff basically the service parameters of an instance from the services branch of NSO with the routines that extract in the first place the service parameters from the OSS database, figure out which ones are different, and then write the new values from NSO back to the OSS database. Now there's a debate to be had about whether your OSS database, and I've had this debate often and loudly with many people, but whether or not the purpose of the OSS database is to represent the intent of how your network should be configured or the state of reality of how it actually is configured, right? And like I said, my mission is not to correct the entire world and make sure that everything is quote unquote right. It's to automate more things. So from my perspective, and it's fine to document it back into, maybe don't overwrite values that are there, but we like to document into fields that indicate that this is a deviation from perhaps the VLAN or whatever that was originally documented. But it gets everything in sync and it helps me achieve my mission of automating more things in the network. And presumably, if that service is already configured on the network, it's presumably already working and the customer is not complaining. So we'd like to do no harm is sort of our first tenet there, and just keep things as is. We've got it documented how it is configured, everything's in sync, and now we can process more automations. So that's sort of the life cycle that we've built and is working for us in its early stages. I'm going to hand off to Scott now from Data Ductus. So when we looked to implement this, we're just kind of, honestly, we have 2 guys dedicated to network automation here full time. So we needed the manpower and expertise that Data Ductus offered, and it's been a long road, and they've been really helpful in this. So Scott, you can take it from here. Scott, I think you're on mute.
Thank you. Am I better now? Yeah.
Yep.
So I think what we heard in terms of at the beginning from Roque and then Rob is that this has been a journey in terms of developing the concepts about how to do reconciliation and what it means and which things get reconciled. But the interesting thing about this is, as well, in terms of developer days, is that it's also a technology journey over the years of service reconciliation itself. And so I'm just going to take you on a quick walk backwards to what I've seen myself at Developer Days over the years, and I imagine many of you have as well. But really, it is a recent and ongoing process and path forward, and we're pleased to be part of it for this year. So back in 2017, we all saw this slide, and this slide it was the beginning of reconciliation. In fact, what I understand is that redeploy reconcile as a command itself was brand new into NSO at that time. And so we saw this, and it was a thorough presentation by Roque, but also complex, and I was actually pleased that no one asked me to do any reconciliation over that next year. But then Dan Sullivan came along, as Rob mentioned, and he came up with a very simple concept. We are good at service to device mapping. We do it all the time in services that are template only. And we take the service parameters, we map them to device, and then we deploy it, and we go forward. And so why not just take the reverse of that from the device model into the service model? And that is reconciliation, in fact. And so not only that, but Dan provided the code that would do the transaction management and also the redeploy dry run to see if there's any differences between the service model and the device model. And if it's clean, that means that the service is would now be in sync with the device. And so you can go ahead and commit the service parameters. And so Dan provided that and a nice presentation. In fact, I have all the URLs for the YouTube videos for these presentations for anybody to go follow through and look at. And then in 2019, Dan followed up with how he did a larger number of instances, but perhaps more importantly, what to do when things didn't exactly reconcile, like what Rob mentioned in terms of maybe your text strings are just case difference, or maybe there's one parameter that actually would be a conflict that you have to raise to a human. So Dan pointed that out, and you can see in the donut there's just a little sliver out of all of those that couldn't be reconciled automatically. So we took all those concepts together, and now we're in 2020. We're back to what Crown Castle and Data Ductus did together. And so hopefully this is a worthy step forward in terms of reconciliation as far as developer days. And so this is how it looks. We have the services and the reconcile actions, as Rob mentioned. But in fact, in this case, there are dozens of services. They are stacked services. So it's even another kind of dimensional shift forward in terms of the implementation. So there are, again, dozens of lower level services and a smaller number of higher level services. Those have to be reconciled from the bottom up, to the lower level service from the device, and then up to the higher level service. In addition, what you heard about was the auditor and the reconciler. Those are the services that respectively run the NSO compliance app. It gets the redeploy dry run output. Is there a difference? Would there be a difference with the network? And then it turns it around, parses it, mines it, pulls out the deviations that we do understand, those that we don't, and then we'll deploy them, extract the parameters and deploy them into the reconcile actions that we've already written. Because this is a lot of software, there's a lot of testing that needs to be done. My favorite currently is the robot framework. The details of that would be a great topic for another session. But essentially, it is a great way to automate NSO testing and basically anything other kind of automation testing. And so with these pieces, I can imagine what's coming next. You need a CI/CD runner to do that all. So we make a change, we add a new reconcile action, we add a new service or a new test in robot. The whole thing runs. It's ready to then deploy out into the network to be picked up daily by, in fact, another CI/CD system that you all know, and that's Jenkins. They're different because they're run by different organizations, but the fact is that all this is fully automated, and so hopefully it is a worthy step forward in terms of reconciliation in 2020, and maybe this slide will be in next year. So, but it wouldn't be developer days if I didn't show some code. And so how did we do it? That before was what we did, and this is how we did it. We did start with Dan Sullivan's code, and as I said, what it does is it does the transaction management and it does the redeploying or the redeploy dry run of the template, and then it checks the output. But with dozens of services, we needed to not have that code spread out across all those services in Python actions, when in fact they were all template only services anyway. We don't want that also because not only because it's spread out, but also because each Python instance would require a new VM, and that's a lot of memory to get used up just for the off chance it needs to be reconciled. So we moved it all into a centralized location and abstracted it into a base class pattern, such that the only thing you have to do to add a new service into the add a new reconcile action for a new service is to add these parameters here on the right, which are those things which can't be gleaned automatically from the code. These are things like the path and the variables and the log string. I mean, you can imagine those are the things that are not generally reversible. And so you add these things and into our base class, and you have a new service template, or a new service reconcile template. Of course, the real challenge with this is not so much this infrastructure, but it's the business logic that is in fact the reverse mapping template. And so that doesn't just go away. That's still there. And in fact, I'm going to show you that in a second. But I do want to point out that because it is developer days, because it is a community, and we do appreciate all the work that we've gotten from, or all the help we've gotten from people that came before us, we have provided this code out for anybody to go use, look at, use, and in fact enhance if that works. So the last thing is it wouldn't be service reconciliation without the reverse mapping template. In this case, it is a stacked service, and so there's just a few changes, a few differences to think about. So I'm going to show you an example of the stacked service, which is, in this case, it's a higher level service, and fundamentally it is just a template. And so you see the tags that essentially identify the instance, and that variable had to be passed in by the code because we can't automatically glean it. But the trick here is that we had to make a decision. Because they're stacked services, you may have a number of lower level services contributing to the same higher level service. And so one way you can do it is take all the parameters from each low level service and reconcile them forward, or map them forward, and then go on to the next service, and then go on to the next service. Or what we did was to take functional bits in the higher level service, and then all the contributors to that higher level service, that location in the higher level service, and put them into one place. And so, for instance, this happens to be an A location container in this circuit, in this E-line circuit service. And so, for instance, one contributor to that is this handoff subservice. And in addition to all the overhead that's there, fundamentally, there's a port description that gets mapped from the lower level service to the higher level service. Okay, that's fine. But then you get another contributing subservice to this higher level service. And in addition to some things like the policer name and the ACLs and those things, notice that you do have this port description that is mapped from this other lower level service into the higher level service. And that is a potential source of conflict. And so here's the other decision. What do you do about that? In our case, of course, you can see that it is a last one in wins. And then, of course, if they're different, what's going to happen is that when you go and rerun the redeploy dry run, it's going to have a conflict if they're different. And then that either gets kicked off, it gets kicked off to someone, whether it's software that says, hey, you know what, it's just a difference in case, leave it, force it, or maybe it has to get kicked off to a human or something like that. So that's, though, the example of what can happen in this kind of case. Of course, then there are other subservice contributors to this higher level service, and then they just flow like that. And then you would move on to the Z location container, and then perhaps any other service. So that is the technology behind the implementation and behind the journey of what we in Crown Castle did together. And so hopefully that was helpful. Now I'll send it back to Rob for the summary and the poll if we have time.
Cool. Yeah. So just, real quick, I don't want to leave you guys. We weren't trying to communicate that we've done anything revolutionary here. Certainly, we're standing on the shoulders of giants with the work that Dan and Roque and the other solutions architects have done in the past, and others on the dev website. But I just wanted to kind of show you guys a practical case study on how reconciliation is being managed within Crown Castle. That it can be done. That the tools and the patterns, right, are more mature now than they were back then. There's a lot that's been done, studied, communicated about how to do this properly and easily. And I think that you shouldn't operate under the delusion that you're going to get to 100% automation and not have to worry about reconciliation. I think that it's more important to come up with a strategy for how to deal with the full life cycle of both human-machine interactions for a service. And like I said, I don't have all the answers. Maybe in 2021 we'll see it developed further. My wish list personally would be to see some sort of more reconciliation functionality built natively into NSO. Like I said, you can't always deterministically map everything from devices back to services. So maybe you can't 100% have a reconcile function that just does magic and reconciles your services. In fact, I know you can't. But something to kind of help with that process. There's some patterns that I think most people would benefit from. And a really hard problem turns out to be finding what's not there. It's easy to see that this leaf should be set to this, let's say, bandwidth should be set to 100 megs, but it's actually set to 200. That's easy to kind of find and fix, but it's hard to find out what other things are set on your maybe interface settings that shouldn't be there in the first place, and they're not addressed in your template, so NSO they don't get flagged in your sync check. And then the other thing that we found is one of those common patterns is that if you can pick a few leaves from one of your services and assume that those are correct, a host name and a port perhaps, usually that'll lead you to an anchor container or list. Maybe it's a VLAN subinterface, maybe it's an access list, where then you can discover the other parameters, right? So there's some patterns there in terms of discovering your context and then auto discovering the values inside of that context that I think it'd be worthwhile doing some studies on that. And then I don't know if we have time now, okay, but if you guys have any questions, I'm happy to stay and answer them. But I know you guys have other presentations you'd like to go see as well. So thanks for being here today.
Yes, thank you.
Okay, so thank you, Rob and Scott. We had a poll going on. So let me quickly go through the results. I don't know if, so the first question was, what's your source of truth? And unfortunately, the results are in the app, if you look at the app. So I guess the result will not surprise that 71% believes the source of truth is the network, all right? Now, 29% is actually a combination of basically all the aboves, OSS, NSO, other orchestrator of the network, similar to what you mentioned, Rob, correct? Now, the second poll, here we got a more diversity. We were asking, when do you think will reconcile your network? So 50% answer that it's done on demand or before a configuration push. We have 25% answering that is done daily. And then we have a tied for the third position between with 12% that is done either once when you first onboard NSO or actually never. It's perfect greenfield environment. So do we have a question for maybe our last question? We got one question here from Abrar. Question is, do you manage reconciliation as a separate service package in NSO, or is that part of the original service package?
Right, so we actually manage it as a separate service package, and the reason being is that there's a Python stub of code that needs to get executed to kick it all off, and that's actually the code that Scott made available publicly that you can go check out. So that code needs to kick everything off, and if you do that in every single individual service package, you're running lots of, in our case, dozens of Python VMs, and so just for sort of a memory resource standpoint, we decided to have a separate package for that and just running a single VM that manages the reconcile actions for all of our different services.
Okay, fantastic. So again, thank you very much to our big audience. We had actually 120 people in the Hive.
Cool.
We give you 30 seconds back so you can switch to the next session. So, and thank you, of course, to our distinguished speakers, Rob, Scott, and see you next year in our next reconciliation conversation.
That's right. All right, thank you.
Thanks, Christian. Thanks, everybody.
Thanks, everybody.